Okay, I think we're done with tangent. Let's go on to the next thing, which we call sine and cosine. And I want to show you some really cool things and how these are very, very, very similar to tangent. Check this out. Here's our triangle again. Again, eyeball method. Label it because guess what? There's our hypotenuse, and guess what, sports fans? We're finally going to use it. Oh, happy, happy, joy, joy. There's our reference angle. There's our eyeball staring over at our opposite. And of course, A, DJ, play me a decent song. There's adjacent right there. Now, I want to show you something. Sine ratio over here means the sine of that angle. Notice that this is angle A here, right here. Okay, the sine of this angle is opposite over hypotenuse. In cosine, cosine here is now adjacent over hypotenuse. How are you going to remember this? Well, do you remember TOA? Remember tangent? TOA? Well, I'm going to teach you all the other things that go along with TOA. It's actually quite cool. It's called SO, KA, TOA. And you know that tangent is opposite over adjacent, but check this out. If you go SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So there's no way of forgetting this. It really, really is straightforward. So let's go on to the next question and let's see what this is all about. Take a look at this great question right out of your textbook. I really like this question. It says, write the trigonometric ratios. Let's do all the angles of A first. So I'm going to do this guy and this guy first, and let's see what happens. So A says, tell me sine A, and then B says, tell me cos A. All right, well, wait a second. Label your triangle. Notice how I've always labeled the triangle before I've done anything. A is here. So that means eyeballs looking over here. That is our opposite, just like before. There's our adjacent. Notice this is no different than tangent. It is not any different than tangent at all. The only difference is now I've got this hypotenuse that I'm actually going to start using. Case in point, look what happens when I figure out the sine of A. Sine of A, remember? SO. Right? It's SO. Sine of the angle is opposite over hypotenuse. So the opposite here then is 4. The hypotenuse here is 5. There's your ratio. You can leave it as a fraction or you can put it in decimal. I don't care at this point. Look at cosine of A. Cosine of A means, if this is SO, this is KA, okay, which is your adjacent and your hypotenuse. So cosine being cosine theta is adjacent over hypotenuse. Your adjacent now is 3. Your hypotenuse is 5. This is 3 over 5. There's your two ratios. Let's do this again now in green for these two. Now again, sine of B. Now, the important thing here is we have to go back, right back to this guy. Yup, all the way. I'm going to clear all this out of here. We have to go right back to this guy because guess what? Because we're dealing with another reference angle, yup, we have to relabel our triangle. So again, eyeball method. Notice the hypotenuse has not changed, but we're dealing with a different reference angle, whereas before we were dealing with A, we are now dealing with B. So guess what? This guy is your opposite. This guy is your adjacent, ADJ. Okay? So let's go back. Let's do the sine. Sine, SO of B. So the sine of B is opposite, right over here, over hypotenuse right here. So this is now 3 over 5. The cos, which is KA, is of B, is your adjacent, which is 4 over your hypotenuse. I'm just going to squeeze it in there. 4 over 5. Okay? again, probably the most important thing to notice is what is your reference angle doing, and of course, drawing your triangle based on the reference angle. That's probably the most important thing, is to do a proper setup.